Okay, this problem, we're given a table, and the input to the table is the years since 2000 in T, and the output is the amount of money spent on healthcare in the US per capita in dollars, that's A. And if we come down to the very first part of the problem, it says determine the rate of change of the amount of money spent with respect to time. So this rate of change, we're looking for the average rate of change between the year 2008 and 2011 first, and then we're going to use that to fill in this data here, and then we'll find the average rate of change between the next two set of data points and fill in the rate of change there, and so on down. And then it asks us to explain what this tells us about the situation. So in order to find average rate of change, remember we find the change in the outputs. So 8648.45 minus 7563.05 divided by the change in the inputs, 11 minus 8, and that gives us $361.8 per year. So on average between 2008 and 2011, the amount of money spent on healthcare in the US per capita increased by $361.8 per year. We continue that same process all the way down. And so the next one, 9,727.73 minus 8648.45 divided by 14 minus 11 gives us a result of 359.76. I continue doing that same operation, finding the change in outputs divided by the change in the inputs for each one of the data point pairs. And when I do the next, I get 357.72 and then 355.68 and then 353.64. So if I were to take this number, subtract that number, that gives me the change in the output divided by the difference between 23 and 20. That's the change in the input, and the result is this value here. So we filled in the rate of change column. So this is the average rate of change between successive data points. And we want to know what that tells us about the situation. And so what I can see here is that the rate of change is positive, meaning that our outputs are increasing, and we can see that our outputs are increasing. But we can see that the rate of change is getting smaller and smaller. So even though it's positive, it's still getting smaller and smaller. So this tells me that the rate of change is decreasing. And this tells us that the amount, well, actually it tells us that the change, right, that this change in the amount spent on healthcare, sorry, let me get rid of these extra ofs, and the amount of money spent on healthcare each year, right, so is less and less. Okay, so the amount spent on healthcare is less and less each year. And we can see that because these numbers are getting just a little bit smaller each time. And so that even though the amount of money spent is increasing, it's increasing by smaller and smaller amounts. Okay, so then the next is determine the rate of the rate of change. So let's look at how these values are changing with respect to our change in our inputs. And so it's the same process here. 359.76 minus 361.8, and it's a 3-year time span, and this results in negative 0.68. And if I continue on, 357.72 minus 359.76, again all over 3, again I get this negative 0.68, and I see that if I were to continue that process, I get a constant negative 0.68. And so this tells me the rate of change of the rate is constant and negative. And because of this, this tells us that the rate of change is decreasing by a constant amount of $0.68 per year every year. So let me try to write that out. This tells us that the rate of change is decreasing by a constant amount of $0.68 per year each year. Okay, so $0.68 per year, that is the units of this value, and then it's per year because we're finding the rate of change of the rate of change. Okay, so the amount of money spent on healthcare is increasing. It's increasing by smaller and smaller amounts each year, and the change in the change is a constant $68 per year, and it's negative because the amount of money is increasing by smaller and smaller amounts each time. Okay, so now we're going to use this information, this pattern, to estimate the amount of money spent on prescription drugs 26 years since 2000, since the year 2000. Okay, so in other words, in the year 2026. So we would want to continue this table on. So I'm going to go ahead and kind of make the table a little bit here. So I'll take 20, 23, I'll continue it down to 26. And here in 20, it was $11,867.93 spent in that year. In 2023, the amount of money spent per capita was $12,928.85. We know the change between those two values was 353.64 per year. That's the rate of change per year. We're trying to find what the output was in 2026. If we knew what the change in the output was here, we would be able to add that to the 12,928.85 to get the value that was spent in the year 2026, or will be spent in the year 2026. And so in order to do that, we have to realize that, well, we can only know this value if we know this value, how much the rate of change is changing by. And we know that the rate of change is changing by a constant of negative 0.68. So per year, and this is a 3-year change, so negative 0.68 times 3 is negative 2.04. So that means the change from here to here is 2.04. So 353.64 minus 2.04 tells me that the average rate of change between 2023 and 2026 will be 351.60. And again, I can't just add that to the 12,000 because I know that that is an average rate of change per year, and there's a 3-year time period that's happening here. So this is 1,054.8. So now I know that I would have to add 1,054.8 to the 12,928.85. And when I do that, I'm going to change pen color just so it can be clear. The amount spent per capita in 2026 is projected to be 13,983.65. That's how we use the table to work backwards, because we know we have a constant rate of the rate of change. And that gives us our final answer for that problem. All right, continuing on here to the problem 5. This should really say the data from question number 4 can be modeled by the function A is a function of t, and it is this whole function right here, where t is the number of years since 2000. So explain the meaning of the parameter c, the 4,638.73, in the context of the problem. So we say, according to this model, the per capita amount spent on healthcare in 2000, because that is our vertical intercept when the input is 0. So in 2000 was $4,638.73. So explain the meaning of the parameter b. So the parameter b tells us that initially, right when we gathered that data of $4,638.73, so initially in 2000, right at that moment in time, that number, the 4,638.73, it was increasing at a rate of $368.26 per year. And then it goes on to ask us to explain the meaning of the parameter a, which is this negative 0.34 in the context. So I would say the change in the per capita spending, or the change in the per capita amount spent on healthcare is decreasing at a constant rate. So So the change in the per capita amount spent each year is decreasing at a constant rate of $0.68 per year each or every year, each year or every year, however you want to say that. The important part here is that it's the change. Ooh, I don't want to erase. I wanted to underline. So it's the change in the per capita amount spent on healthcare that's decreasing at a constant rate of 68 cents essentially per year every year. It's the change in the rate of change.